All right, class, today we are going to talk about inverse relations and inverse functions. A relation is just an XY relationship like what is shown in this chart here. So when you're talking about an inverse relationship, all you're talking about is that instead of you inputting this column and getting out this column, you're going to switch them. So your x's and your y's simply switch. So your inverse relationship would be 1, 4, 3, 1 with your outputs of -2, -1, 0, and 1. So you'll notice that we just switched. Now, I do want to remind you that when we talked about like inverses of numbers, so like if we wanted, this is a little like extra notes in a different part of your notebook. If we wanted the inverse of 4, we would write that as 4 to the -1, and that gives us 1 over 4. Negative exponents move that down to the denominator, and then when we multiply those inverses, we get 1. So 4 times 4 to the -1 gives us just the number 1, okay? So this is kind of just something to kind of have in the back of your mind. So a relation is any set of ordered pairs where x is the independent and y is the dependent variable. An inverse relation is formed when the roles of your independent and dependent variables are reversed. So what happens is you end up putting in, those are your inputs, and then these are your outputs. If an inverse relation is a function, if the inverse relation of a function is a function, it is called the inverse function of f, which is written as f and then to the -1 like this, f inverse of x. That's an f. Let me erase that and try to write it a little more plainly for you guys. Sorry. It's going to be f to the -1 of x. Okay, so now let's look at example 2. So example 2 is showing us how to find the inverse of a relation. When you're looking at it algebraically, there are 2 steps. Your first step, and I'm going to I'll write the steps out here. Your first step is to change from function notation to linear notation, meaning that f of x is just y. That's all you have to do. So our first step is to change our f of x to a y. So I'm going to write y equals x squared as my first step. Then your second step is to swap your x and y. So remember, it says that your input becomes your output and your output becomes your input. So you're just going to swap x and y. So to do that, I'm going to write x equals y squared. And then your third and final step is to solve for y, meaning get y by itself. So there's your 3 steps. So to get y by itself again, I'm going to change colors here. We're going to take the square root of both sides. So we get the square root of x equals y. And then finally, your fourth step is to, and I'm going to erase this so that on your steps it doesn't show up. Your fourth step is to rewrite in function notation using notation using f inverse of x. So now we're going to replace that y with f to the -x of y equals square root of x. Okay, now what do these look like? And you're also, one other thing. When you take the square root of a variable, you have the positive and the negative of that square root. So with this, it asks, what do the graphs look like? Well, remember that we know that x squared, let me do that one first, looks like this. And that the positive square root of x looks like this. And the negative, this is x, this is square root of x. And this down here is negative square root of x. So if you look at those, they kind of, it looks like a rotation. And if I highlighted this line right here, I'm going to draw this gray line. This is the line y equals x. And if you folded that graph, whoops, did I close it? Sorry, guys. If you folded that x on that line, I hope you drew that on your paper while I pull this back up here. If you folded this on that diagonal line, your blue line and your green line would touch. Okay, so now let's look at example 3. The problem with the 2 is that this blue line is now no longer a function because it doesn't pass the vertical line test. It now touches that vertical line. So this is not a function. So what we have to do is anytime we have symmetry like this, we have to realize that there's actually 2 y's that repeat. So we have to take out the repetitions. So when we restrict the domain, which is what example 3 asks us to do, we need to remember that we only want this half. So for this, our domain is going to be x greater than or equal to 0. Okay? I hope that makes sense. So now, once we do that, then our inverse is just that top half. And then our original looks like this, and we've got it. This isn't so much as you just need to understand domain and range for that. Which reminds me, if we go back to this, your domain of f of x. So let me make a little chart here. So we have, go back guys, sorry, put this in your notes. We have f of x and f inverse of x. And let's say we have the domain and the range. Well, for f of x, this is x squared. This is square root of x. Our domain is negative infinity to infinity. And our range in the green there, this is the green side, the green, our range is 0 to infinity. Well, if we look at our blue, our domain for our blue, it starts at 0 and goes to infinity, but our range is negative infinity to positive infinity. So notice that when you go from the inverse relation to the actual relation, that the domain and the range swap roles between those two. So when you think about this, your domain here is going to be x is greater than or equal to 0 on your original, and your range is going to be y is greater than or equal to 0. So then when you think about this function over here, the inverse, your domain is still going to be x greater than or equal to 0, and your range is y greater than or equal to 0. So with this one, that still swaps there. All right, okay, we're going to pause the video at this point, and then we will do 4, 5, and 6 all on another video.